In this video, we're going to be taking a look at 4.4, getting real with irrational numbers. So far, we've looked mostly at rational numbers. Here, we're going to be taking a look at irrational numbers. Right, so we've looked at irrational numbers a little bit, but we never really discussed them. We've only said that they are not repeating and not terminating decimals. And that's basically the definition of an irrational number, which is that they are non-repeating and non-terminating decimals. So make sure that's down in your notes so you know what irrational numbers are. You should also have what rational numbers are from 4.2 or 4.3, and then what terminating and repeating decimals. Those are all terms you should be very familiar with at this point. Now, irrational numbers, that's kind of a new term, but it's essentially non-repeating and non-terminating. Now, earlier we've looked at some examples, like right here is an example of a decimal that never repeats or never terminates. Here's another one. The difference between these two is that this one right here has a clear pattern. Like it goes 0.12, 122, 1222, 12222, and so forth. But this one has no pattern. This one has a pattern. But either way, both of these are irrational numbers because they go on forever, they never repeat, and they never terminate, means they are irrational numbers. And because they're irrational numbers, they can never be written as a fraction. That's really important. So irrational numbers can never be written as a fraction. Okay, so remember that. So all of these down here, these are not irrational numbers, but they are very close approximations to that irrational number there. Okay, so those are irrational numbers that we've been talking about. Now, the reason we're talking about irrational numbers at this juncture is because square roots, a lot of square roots create irrational numbers. For example, this right here, that's an irrational number. If we plug that into our calculator, you end up getting 3.3166247, yada, yada, yada. It never repeats, never terminates. Right? That number cannot be written as an irrational number. However, in this case, this is written as a square root. Okay, and probably one of the most important takeaways from this section is going to be right here. How to determine if a square root is irrational or irrational, like this is irrational, is right here. Write this in your notes. I'm highlighting exactly what I want you to write in your notes. Square root of n can be any number, is an irrational number for any whole number value of n that is not a square number. So write that down, and then we're going to talk about it. And once you've written it down, highlight it. It's extremely important. One of the most important things you can take away from here. So we're going to do some examples. So for example, if you look at square root of 2, is 2 a perfect square? Right? Remember, if you look at our perfect squares, they are 1, which is 1 squared, 4, which is 2 squared, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, and so forth. Right? These are perfect squares. Square root of 2 is not a perfect square, so then that means that this is going to be irrational. Square root of 3. 3 is not a perfect square. That means this is going to be irrational. Square root of 4. 4 is a perfect square, so that means this is going to be rational. And in fact, square root of 4 is just 2. Because remember, square root says what number times itself will give me this number. 2 times itself gives you 4, so square root of 4 is 2. So that's a rational number. Right? Square root of 5, and so forth. Square root of 6. These are all irrational numbers. Okay? So remember that. If n is any number that's not a perfect square, then that means it's irrational. So if we look at these, are the following numbers rational or irrational? Look at this, 7, that is not a perfect square, so then that's going to be irrational. 9 is a perfect square, so that's rational. Now this is tricky, right? 0.25, but 25, that's a perfect square, right? That's 5. So this is actually a rational number. You can take the square root of 0.25, and you will get a repeating or terminating decimal. Okay, so these set of irrational and rational numbers, these are what we call real numbers. So the set of irrational and rational numbers, that's called real numbers. So write that down. Write that definition of real numbers down. It's a set of rational and irrational numbers. Let's go ahead and take a look at A, 1 and 2. On 1, it says write 3 or more non-terminating and non-repeating decimals that are greater than 0.5 but less than 0.6. Now, the interesting part is that right up here, there's actually an infinite number of answers, so there's no set of exact right answers. There are definitely wrong answers and definitely right answers because it has to be between 0.5 and 0.6. So try this on your own, just A, number 1. Okay, so if you tried this on your own, they have to be like, here's our number line, here's 0.5, here's 0.6. Has to be somewhere in between. So for example, 3 or more non-terminating, non-repeating. So 0.51 will not work. But if you have 0.5, 1, 2, 3, 8, 6, 2, 1, 4, yada, 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 that's an example. That's between, right? Or 0.59, 599, 5999, and so forth, that works as well. So anything in between 0.5 and 0.6 that does not repeat and does not terminate will work for that one. On 2, it says, why is there no limit to the number of non-terminating, non-repeating decimals that are between 0.5 and 0.6? Well, there's an infinite number of options. Since these decimals can go all the way out there to infinitieth, right? Then there is, we'll do that. There is no limit as to what you can do because you can keep putting numbers just randomly, so there's no pattern, on and on and on forever, and then take 1 off for the next one, add 2 for the whatever, right? It can go on and on and on forever. Let's take a look at B. Write a rational number estimate for the square root of 5 that is less than the square root of 5 and greater, and one that is greater than the square root of 5. Write a irrational number. So 1 is asking for a rational number, so that is a terminating or repeating decimal. Number 2 is asking for an irrational number estimate, so do not use a calculator in part B. For square root of 5 that is less than square root of 5, and one that is greater than the square root of 5. Go ahead and do part B and then come back to the video. Okay, so you know the square root of 5 is between the square root of 4, right, and the square root of 9. Square root of 4 is 2, square root of 9 is 3. So a good approximation is going to be about 2.1. Or 2.2, between 2.1 and 2.2, something like that, right? And so the first one says write a rational number estimate. So right there, that's 2.2. And then a rational number estimate greater than. Rational number estimate greater than, right here. We know that it's going to be a number that's probably really close to 3. So maybe one that's greater than would be 2.9. So square root of 5 is likely between those two values. If you want to, go ahead and find the square root of 5. I think that was one that we did up here. No, that's square root of 11. So if you find the exact answer for the square root of 5, I think it's something like 2.23. But the square root of 5 is exactly 2.2360667, yada, yada, yada. Right? So yes, this would work. This is an underestimate, and this would definitely be an overestimate. And those are both rational numbers. Now, on the next one, if you haven't tried this, pause the video and try this on your own. But on the next one, it wants an irrational number approximation. Right? So let's go off of 2.2 and make sure it's less than this, though. So let's do 2.121221222 and so forth. So that would be an underestimate. And then one that is greater than that would be, let's go off of like 2.9. It just has to be greater than this. So 2.912764139814, yada, yada, yada. Just something that does not repeat will work for that one. And let's take a look at part C, 1 and 2. The diagram, it shows a square drawn on the hypotenuse of a right triangle. We've done this many, many times. Find the lengths of the sides of the square and the area of the square. We've done this many, many times, right? Now, it says if you use a ruler to measure the hypotenuse, so if you use a ruler to measure this part right there, how accurate can you be? Explain. So first, I want you to find the length of that hypotenuse. Now, the hypotenuse ends up being, you're using the Pythagorean theorem right there, ends up being the square root of 5. That's the length of that hypotenuse. Now, remember, the square root of 5 is an irrational number right here. That decimal never stops, never repeats. So how accurate can you be, right? When you're trying to measure an irrational number, you will not get very close. Right? That's why it's always better to leave your answers as square roots, because that gives you the exact answer, not an approximation. So then on number 2, if you haven't done number 2, pause the video and try this on your own. It says, Ty says that this proves that square root of 5 times the square root of 5 is equal to 5. Do you agree or not? Yes, I would absolutely agree with him, because if you look here, right here, c squared is equal to 5, and c squared is the area. So if the area is equal to 5, then the side length has to be equal to the square root of 5. Therefore, square root of 5 times the square root of 5 has to be 5. So yes, I would agree with him on that one. Now let's take a look at part D. It says, tell whether each number is rational or irrational and explain your reasoning. So go ahead and use whatever methods you can to explain numbers 1 through 12, whether it's irrational or rational. And it can be as simple as, listen, if it's rational, it's a repeating decimal. If it's rational, it could be a terminating decimal. If it's rational, it can be a whole number. Any of those. Like, for example, looking at number 2, square root of 16. Well, hey, that's equal to 4. And it's rational because it's a whole number. Okay, so it's very important that you just put a quick explanation of why it's rational or irrational, because you will be expected to do the same on tests or quizzes. Go ahead and go through numbers 1 through 12 and then come back to the video. Okay, number 1, this is irrational. And it's irrational because, remember, if you take the square root of a number and that number inside is not a perfect square, then it's always irrational. So it's irrational for that reason. It's going to be a non-repeating and non-terminating. Number 2 we did. Number 3 is going to be rational because square root of 4 times the square root of 4, that's equal to 2. Now when you're doing these, make sure you rewrite each of these like you would rewrite in your notes the square root of 4 times the square root of 4, and then put that equal to 2. And that is a rational number because it is a whole number. right? Just like the last one, it's a whole number. Same with number 4, it's rational because it's a whole number. Square root of 7 times the square root of 7. This 5 that's an irrational number. Again, square root of 7, that's an irrational number. So an irrational number times 2 will always be an irrational number, right? So an irrational number times any number will always be an irrational number. Then number 6, this is irrational because 28 is not a perfect square. Number 7, this too is irrational because 14 is not a perfect square. Number 8, that's rational, right? Because 1 and 16 are both perfect squares. That will simplify down to 1 over 4, which is 0.25. So that is a rational number, number 8, because 1 and 16 are both perfect squares. Number 9, that is a rational number because it is terminating, and you can write that as a fraction. So that is going to be rational on this one. On number 10, this is irrational, or sorry, this is rational because it does repeat. So since it repeats, it is rational. So that one would be rational because it repeats. Number 11, this is going to be irrational because that does not repeat and it does not terminate. Therefore, it's irrational. And the same for number 12. That is irrational because it does not terminate and does not repeat. So again, for each of these, make sure you're rewriting the problem and then writing the explanation next to that problem. Okay, let's take a look at part E. As part of her math project, Angela is making a pyramid. She starts with the net shown below on a centimeter grid. Now you have a lab sheet that already has this for you, so you don't have to necessarily redraw anything. Or you can find those measurements on that lab sheet if you wanted to. So go ahead and answer parts 1, 2, and 3, and then come back to the video to see how you did. Now, number 1 says to find the exact value of Q. Okay, then we're going to explain whether it's a rational or irrational number. So first, let's find the exact value of Q. Let's highlight that side that we want to find right there. So to find that can be the hypotenuse of this right triangle. And so if we draw a side all the way up, that's a right angle there, and that's exactly halfway between. We can actually find those side lengths. Like this is 1, 2.5, so that's 2.5. And this is 1, 2, 3, 4, 5, 6. So that's 6. And when we find the area, or not the area, sorry, using the Pythagorean theorem to find Q, that would be 6 squared. Oops, ran out of room there. That would be 6 squared plus 2 1/2. We'll do that. Squared is equal to Q squared. So you end up with Q squared is equal to 42 1/4. And so Q is the square root of 42.25. Okay, and that is about, or actually, this is exactly 6.5. And that's not in our list of perfect squares. So you would have to be sure, because decimals can be perfect squares too, because 6.5 times itself, that's where the 42 1/4 came from. So you just have to be careful. You could plug this into a calculator to find, you would have to plug that into a calculator. That would be my expectation to figure out that that's an exact answer. And so since that is a terminating decimal, that is a rational number. So now on part 2, what's the exact height, which is h of the pyramid. And actually, I'm going to go back to the book because it shows a better representation, but this is kind of what we're looking at here, where this is what we're trying to find. We know that this is 2.5, and this S is actually this height right here, so that's 6. And I think you can better see that by looking in your book right here on the right side. So here would be your right triangle. Right, that's the right triangle that we're working with. Now let's go back to our lab sheet. We're going to set up the Pythagorean theorem, so go ahead and try this on your own if you haven't already. So you would have h squared plus 2.5 squared is equal to 6 squared. So you'd have h squared plus 2.5 squared, yeah. So what we're going to do is we're going to bring this 2.5 squared over, so you'd have h squared is equal to 6 squared minus 2.5 squared, because you would subtract it from each side. And then you would take 6 squared minus 2.5 squared, which is 36 minus 6.25. So 36 minus 6.25. That's equal to h squared. And so h squared is equal to 29.75. But we want to know the length of h, so we have to take the square root of 29.75, which gives us about 5.45. And if you put that in your calculator, you will get an irrational number. So our best approximation is going to be about, that's what these squiggly lines are, that's an approximate 5.45, because that is irrational. And we can't write an irrational number down other than if it's a square root, because the decimals never stop, and we would never stop writing numbers. And then part 3, it says, will the finished pyramid fit inside a cube-shaped box? So a cube, remember, all sides are the same. That is 6 centimeters wide, 6 centimeters long, and 6 centimeters high. Explain. Go ahead and try to understand that. So let's go back to, again, the text. And this is a good representation. We found the height to be, let's write this down. Our height we found to be, what was it? 5.45. The S was 6, and then the distance across was 5. So let's say this is D, right? So that would be 5 here, and so forth. So will that fit into the box? And the answer is absolutely, because if you have a cube, that cube is 6 inches this way, which will fit. And it's 6 inches up here, which will fit, and 6 inches the other way. So it will fit easily into that cube box because all the dimensions are less than 6 or equal to 6. But this height right here, the height doesn't really matter. That slant height, the overall height is going to be less, which is 5.45. Okay, that is all that I have for you for 4.4, looking at irrational numbers.